which sweep out the sides of the angle with a common endpoint. The common endpoint is called the vertex. We need to refer to more than one vertex. I want to know the plural vertex, which is vertex. So angles are measured in radians or degrees. To translate an angle measured in degrees to radians, simply multiply by pi over 1/8. To translate an angle measured in radians by 180 over pi. For the most part, we'll talk degrees. Several angles are referred to so often that they have been given special names. A straight angle measures 180 degrees. It's basically just a line. A right angle measures 90 degrees, which is perpendicular lines form it. An acute angle is any angle whose measure is less than 90 degrees. It's acute angle. An obtuse angle is any angle whose measure is between 90 and 180. So here we go. Notations. Naming angles can be done in a couple ways. We can name the angle by 3 points, 1 point on each of the sides and the vertex in the middle, or we can name it by the vertex point alone. Also, we can use these symbols before the point. Referring to the measure of the angle, we use this symbol, measure of angle. So, which angles are acute, obtuse, right, and straight? We have, well, let's see. Let's start with FOA. That's this angle right here. And it is, of course, a straight angle. Okay. So the right angles. Okay. Then I have A. I have BOA, which is also acute. I have COB, which is also acute. I have DOB, which is acute, and a lot of acute. DOC, EOF, also acute. EOD, EOD is acute. It's here. EOC, that's acute. EOB, it looks like it might be a right angle. So I'm going to call it a right angle. And then EOA is obtuse. Okay. Two angles with the same starting point or vertex and one common side are called adjacent. So going back to this, angle BOA and COB would be adjacent. In figure 1027, angle DB, must be below us, yeah. Angle DBC and CBA are adjacent. Two angles are supplementary if the sum of their measures equals 180 degrees. In figure 1028, we are given that the measure of angle FBE is 35 degrees. What is the measure of angle ABE? Well, note when we add them all together, we're getting a straight line, which is 180. So this is equal to 180 minus 35, 145 degrees. Solve for the angle measurements in the figure below. We have two angles, and our measurements are 5x and 2x plus 5. Now we see when we add them together, we get a straight line, so we know that they're supplementary, so that should be 180. So I combine my 7x, I subtract my 5, and if memory serves me correct, x equals 25 degrees. Okay, so supplementary angles measure a total of 80 degrees, 180 degrees. Two angles are complementary if the sum of their measures equals 90 degrees. So we have angle ABC, which is 30, and angle ABD, which is 90. What is CBD? Well, simply 90 minus 30, or 60 degrees. Find the measure of each angle in the illustration. So what do we have here? We have three angles measuring 6x, 9x, 7x plus 2. When we add them all together, we're going to get a right angle, right? There's our little symbol. This is equal to 90. So 15, we have 22, x equals 88, so x equals 4 degrees. So this would be 28 plus 2, or 30. This would be not 4%, 4 degrees. 9 times 4, 36 degrees. This would be 6 times 4, or 24 degrees. When two lines intersect, the opposite angles are called vertical angles. And vertical angles have the same measure. Figure below, the figure shows two straight lines intersecting each other. One set of opposite angles shows angle markers. These angles have the same measure. That's why we have this. The other two opposite angles have the same measure as well, and we could signify that by going like this to show that they're equal to each other, but not to the other two. So, given two intersecting lines in the figure shown, the measure of angle 2, which they failed to label, is 67 degrees. Find the measure of the remaining angles. Well, we automatically know the measure of angle 4 is 67 degrees because they're vertical angles. Then we know angle 1 and angle 2 is 180. So the measure of angle 1 is equal to 180 minus 67, which is 113 degrees. And then 1 and 3 are vertical angles, so the measure of angle 3 is simply the same, 113 degrees. Next concept we have is called transversals. When two parallel lines are crossed by a straight line or a transversal, 8 angles are formed, including alternate interior angles, alternate exterior angles, corresponding angles, vertical angles, and supplementary angles. So in the figure here, angles 1, 2, 7, and 8 are called exterior angles. They're on the back, on the bottom, on the outside. And 3, 4, 5, and 6 are called interior angles. So first concept we deal with here, alternate interior angles are interior angles on opposite sides of the transversal and have the same measure. For example, in the figure here, angle 1 and angle 6 are alternate interior angles and have equal measures. 4 and 5 are alternate interior angles and have equal measures as well. Alternate exterior angles are exterior angles on the opposite sides of the transversal. Here we show angle 2 and angle 7, and they have equal measures. Likewise, 1 and 8 would have equal measures. Corresponding angles refer to one exterior angle and one interior angle on the same side as the transversal, which have equal measures. So here again, we're talking 1 and 5 are corresponding angles, 1 and 5, and have equal measures. 3 and 7 would be corresponding angles as well. So would 2 and 6 and 4 and 8. So you live on the corner of First Avenue and Linto Street. You want to plant a garden in the far corner of your property and fence off the area. However, the corner of your property does not form the traditional right angle. You learn from the city that the streets cross at an angle equal to 150 degrees. What is the measure of the angle that will border the garden? So this angle here, which would be the same as this angle here, which is supplemental to this angle here. So we're looking at 180 minus 150, 30 degrees. In the figure given below, the measure of angle 1 is 120 degrees. Find the measure of angle 5. Well, they have the same measure. So angle 5 would be the same 120 degrees. Now what about angle 4? Well, angle 4 is a vertical angle to angle 1. Then the measure of angle 4 is also 120. And number 8, same thing. Measure of angle 8 is going to be equal. Vertical to 5. In the provided figure given, given that the measure of angle 2 is 48 degrees, find the measure of angle 1 and 5. Well, first, they're going to be the same, and they're going to be, so the measure of angle 1 is equal to 180 minus 48, which is 132 degrees. All right? So that means the measure of angle 5 is all. All right. So we have a whole bunch of angles here. Let's see what we got going on. 6, measure of angle 7, angle 8, and the measure of angle 9. Okay, let's start with the easy ones. 62 here, 62 there. Vertical angles. See, what else do I need? I need 9. Well, this is just 180 minus 62, which is 118. So 9 is 118, which means 7 is also 118. Okay, 5 and 6. So I need 5 and 6. Okay, so what do we have going on here? What do we call this? Not ulterior. They're not alternate exterior. So we're looking at corresponding angles here and here. So this is 62 as well. Okay. This line, this line. All right, come back. So that means 6 is a vertical angle as well. So it's 62 degrees. And so now I have 62 plus 62, which is 120. The measure is that, and I get 180. So we have 180 minus 124, which is 56. So 56 degrees. And there we are. And that finishes up angles.